Okay, so this is 5-6 part 2, which is focused on dividing decimals by whole numbers. We started this yesterday, and now we are going to continue this work. So here's our problem. 8 friends bought movie tickets. The total cost was $78. How much did each friend pay? So this doesn't seem like a decimal number, but it is. We have our $78 divided by 8 people. When we start dividing, we're going to divide as normal. 8 goes into 7 no times because 7 is less than 8. So 8 goes into 78 9 times. And when I subtract that, I'll have 6. Now, these six friends went to the movies, and they have what looks like a remainder of $6 that they had to split up. I can't say, well, there's a remainder of 6. Too bad, movie theater, you don't get those $6 because we can't split it up equally. We have to split it up as money. Now, we know that there is a decimal hiding right there between our dollars and our cents, or between our whole numbers and our decimals. So I can put that up in my answer, and I know that after that decimal, or after any number really, I can put as many zeros as I want, and it doesn't change the value. So I'm going to put one of these kind of ghost zeros or trailing zeros behind, and I'm going to use it to continue dividing. And I'll bring it down. And now I'll ask myself, how many 8s fit into 60? And 8 goes into 60. 5 times would be 40. 6 times would be 48, so 7 times. And that's 56. But I still have money down here. So I'm going to add yet another 0. Bring it down. And 8 goes into 40 5 times, which gives me a remainder of 0. So I can see that each one of the friends paid $9.75, which makes sense. Okay? Makes sense. 75 cents. So what I did here was I used ghost zeros or trailing zeros to continue dividing out into my decimal place. Even though I didn't have a decimal initially, it was hiding there. We knew it was there all along. Let's look at this one. June rode her bike to the bookstore and back. According to the bike's odometer, the round trip distance, and now round trip means, she was at home and she went to the bookstore. So she went to the bookstore and then back home. And that was a distance of 6.65 miles. So the whole thing was 6.65 miles. How long did she travel for just that first half? So I'm going to divide, because I had 2 parts. I want to know what was just in that first part. I'm going to stick that decimal up there now before I forget it. 2 goes into 6 3 times, which is 6. So I must be done? No? Oh no, I need to bring these down too. And it goes into 6 3 times. Oh, but it goes into 5 only 2 times. And I have a remainder of 1. Now, I don't want to use the remainder. I want to use a decimal. So I'm going to give it a ghosting or trailing 0. I'm going to bring that one down. I changed it to a different color so you can see that I added it on. Remember, it doesn't matter how many zeros I add after the last digit. It doesn't change anything. So I would divide 10. 2 goes into 10 5 times, and now I'm out of space, but you know that 10 minus 10 is 0. So Now I'm done, and the answer is 3 and 325 thousandths. So this is a process I can use when I don't want to have the remainder. And as you go up higher and higher in math, they don't want to see remainder something. They want to see down to the decimal point. Let's look at this one. 6 goes into 54 9 times. I'm going to bring that decimal right up now so I don't forget it. That's 54. 0. I'm going to bring down that 7. 6 goes into 7 one time. Bring down that 5. 6 goes into 15 twice. And now I have a remainder of 3. Remember, we're not going to have a remainder. We're going to add a ghost 0 and bring it down. And 6 goes into 30 5 times. So my answer would be 9 and 125 thousandths. Let's do another. Put my decimal up there before I forget. Now, I could come all the way over here to 141, but I don't need to. It can make my life easier. 5 does not go into 1, but it does go into 14. 5 goes into 14 twice. That's a 10. 41, after I bring that 1 down. 5 goes into 41 8 times. That's 40. 1. I'm going to bring down my 2. 5 goes into 12 twice. That's 10. Now I have a remainder of 2. I have nothing to bring down, so I'm going to give myself something to bring down. And 5 goes into 20 4 times. So my answer would be 28 and 24 thousandths. Oh, this one doesn't have a decimal. It's like that one we did all the way back at the beginning about the $78. We know that we can add the decimal if we need it. So let's see if we'll need it. 8 does not go into 3, but it does go into 31. 8 goes into 31 3 times. That's 24. If I subtract, that's going to be 7. I'm going to bring down my 0. 8 goes into 70 8 times. 64. Okay, I have a remainder of 6. So I'm going to give myself one of those imaginary zeros. Now, I gave myself an imaginary 0, but there's no decimal. I have to put the decimal in. The decimal's always after the ones place. So I'm going to stick my decimal in there. I'll put it up in my answer too so I don't forget. And then I'll bring down that 0. Okay, so 8 goes into 60 7 times. So 56, 4. I'm going to put in another 0, bring it down. And 8 goes into 40 5 times. I'm out of space. 40 minus 40 equals 0. That would be down here, but I'm out of space. So my answer is 38 and 75 hundredths. Okay, so I'm going to give you one to do. And let you work on that. How about you do... No, I'm just being nice. Stop there, and you can work on it more in class with me tomorrow. See ya!